Today's May 20th, and we're going to talk about solving, or not solving, volume of solids with known cross sections, okay? So we're going to do volume still. This is the last day, okay? And what we've been doing is been rotating, right? And that rotation caused either a disc or a washer, okay? So now what we're going to do is we're going to tell you the shape, okay? In some way, we're going to tell you the shape of the cross section, and then we're going to get the area of that and then times the dx, because this is going to be the thickness, okay? So if we're perpendicular to the x-axis, it's going to be dx, okay? And you'll understand a little bit more later, okay? And if it's perpendicular to the y-axis, our shapes that we're stacking, okay, it's going to be dy. So I'm going to show, before we get into like area formulas, because that's what this first page is all about, okay? I want to show you kind of a demonstration so you kind of get the grasp of what we're doing, okay? Okay, so what we have here is a circle, okay? And from the circle, we're going to create chords perpendicular to the x-axis, okay? So I'm going to show you these chords. Chords are just line segments connecting across a circle, okay? So I'm going to create those, and you see those in gray, okay? And then I'm going to show you, well, okay, I'm going to drop it flat. So now this would be like our desktop, and then we're going to pull, and what we're doing is we're going to create a solid by all of these chords being sides of a square. Okay, so I'm going to show you 4 squares, and so there's my 4 squares, okay? And the bottom is from the top of the curve to the bottom of the curve, right? The side of the square, okay? And then I'm going to sweep one of them here. And so that's showing you the squares are getting bigger as you go across a circle until you hit the diameter, and then they start to shrink again. And it comes to a point right there, okay? All right, so now let me show you the solid. This is the solid that's created. It's kind of funky. And right over here, it's going to come down to a point because that circle becomes, or not circle, the square becomes a point, okay? So this is what the solid looks like. Okay, here's what 4 squares look like. Okay, and this is what one of them looks like inside of it. Like as you sweep across. So these squares, that's the cross-section area. It's a square, okay? And how we get the area of that square is side times side, okay? And the side comes from the top minus bottom, okay? All right, let me show you one more of these. Let me stop this. Let me go to the next one. Okay, same idea. Let me reset it. Same curve, but this time, here's the chords, but it's going to be different. It's going to be equilateral triangles. So the solid's going to be different, okay? So the base of it's going to be equilateral triangles right there. And if you don't remember what an equilateral triangle, it's a triangle with 3 sides the same length, okay? And that means all 3 angles are the same, so each angle would have to be 60 degrees. Okay, so I'm going to sweep one of them. And at the end, it comes down to a point too. And the largest triangle's right here, where it's the diameter of the circle. So we'll create the solid. And then show the solid. And then there's 4 of them in it, okay? And then here's another one, okay? Let me reset it. There's the chords, and it's already tilted so you can see these, okay? So these are going to be right triangles. Yeah, these are right triangles, okay? So the right triangle with one of the legs being one of the chords, okay? So again, this bottom edge of the right triangle, you know what? And they tell you it's an isosceles right triangle. So this leg and this leg have to be the same, okay? And so 1/2 this times this, and then we'd get it for you, okay? Create the solid. This is what this one's going to look like. And right there, it's going to be the maximum right triangles, maximum area for the right triangle. And that'd be the solid that would create, there's 4 of the triangles, okay? And then here, I think I have a different one, okay? So here's this one. We're gonna drop the y-axis flat, okay? I forgot to show the segments. Okay, hold on, let me go back. So these are the segments. Okay, so this is going to be perpendicular to the y-axis. Okay, we're going to drop it flat. And we're creating semicircles, so half circles. Okay, and so there's our semicircles. Okay, the biggest semicircle is going to be back here at the back, and the smallest one, and these semicircles right here, they become a point. Okay, so we'll sweep one of them across. So you see it's getting smaller and smaller and smaller and smaller. This is what the solid would look like. Kind of like a half cone. So it'd look like that. Sliding one of them through it. Okay, and then we won't do this one. Okay, I just want you so you have like a visual of what these look like, because we can't really draw them because they're coming up off of our paper. Okay, I'll try to explain it as we do it. Okay, but it's difficult without seeing something like this. Okay, all right, let's go back to our paper. Okay, so what we want to do next is I want to go through how do you find the area of these. Okay, so for a rectangle has 4 right angles. Okay, and the shorter side is usually called the width and the longer one's the length. Okay, or sometimes they'll call this one the height and this one the base. So the area is equal to base times height, right? Base times height, or some people call it width and length. So this would be also length times width times length, doesn't matter. Okay, so so semicircle, all right. A lot of times this is the diameter, right? D for diameter. Okay, and what we need for the circle is this. Okay, and that's the radius, right? So the area would equal 1/2 pi r squared. But if you're given the diameter, if you know the diameter, how do you get this radius? Well, you have to take half of it, right? So the area for this would be 1/2 pi times the diameter divided by 2 squared, and then you could clean that up. Okay, I don't actually, let's do this and we'll clean it up when we get to these problems. Okay, because really I want you to understand this concept right here, not you have some formula memorized. Okay, all right, so let's go to the squares, and there's 2 different ways we can see squares. Okay, so if this is the side that we're talking about, then all we would have to do is take a side and times a side. Okay, so a square, all 4 sides are equal in length. Okay, so the area for a square would be just s squared. Okay, now a lot of times they'll give you this, and that's they'll give you it's the diagonal of a square lays on the flat surface. Okay, so this is the diagonal. How do we get the diagonal? Okay, how do we get the area of a square if we know the diagonal, right? And you can do it, okay, because these 2 sides have to be the same. So you could still call these sides, okay, but how do you get these 2 sides from this, right? So remember, these are 90s, right? And if these are isosceles triangles, that means these 2 angles have to be the same from math 2. And so each one has to be 45 degrees, right? So you have a 45, 45, 90 right triangle, okay? So you could set up a proportion, okay? Or you could do Pythagorean theorem, right? So you could do it like this: s squared plus s squared is equal to d squared. S squared plus s squared would be 2s squared would equal d squared, right? And then that would mean s squared is equal to d squared divided by 2, okay? And s squared is the area, okay? So you could get the area is equal to s squared, which is equal to the diagonal squared over 2, okay? There's other ways to do this, okay? So I don't have to say, oh, this is the only way, okay? So it's always the diagonal squared divided by 2, okay? How about for an equilateral triangle? Okay, so an equilateral triangle, okay, let's call this the base. So let's call each one of these the base, okay? And we know each of these angles is 60 degrees, or at least we should. Okay, and this angle up here is 60 degrees. And so this side is base 2, right? If it's an equilateral triangle. But if we drop an altitude, which is also a height, okay, so this is the right angle, and if that's 60, now this angle has to be 30 degrees, and this angle also has to be 30 degrees, right? Okay, and if this is splitting the angle up here, right, it's also splitting the side here. So this is the base divided by 2, and this would be the base divided by 2, okay? And so we need this height right here, okay? And so the one way to get that height, right, in terms of, because it's going to be this side, you're going to have the base, okay? All right, so if, usually we have what's a 30, 60, 90, and this, the short leg, right, which is the one opposite the 30 leg, or 30 degree angle, is usually 1, right? So if this is 1, to go to this one, we have to multiply by square root of 3, right, to get the other leg, okay? Because this leg would be square root of 3, this leg would be 1, and this leg would be 2, right? So to go from this leg to this leg, we have to multiply by the square root of 3, okay? So this height is the base divided by 2 times the square root of 3, okay? So that would be b square roots of 3 over 2. Well, we know that the area is equal to 1/2 the base times the height, right? And so we can replace the height with this b squared roots of 3 over 2. So that would mean the area is equal to 1/2 the base times the base square roots of 3 over 2. Or the area is the base squared, square root of 3, all over 4, okay? And that's just one way. Now, I don't want you to memorize this. I want you to understand where it comes from, okay? So remember, to go from the short leg to the long leg, we multiply by the square root of 3. And to go from the short leg, we don't need this one because that one's the base. But to go from this one to this one, we multiply by 2. This one's always twice this one, and this one's always square root of 3 of this one. So you got to get to this short one, okay? Okay, so those are the formulas, basic formulas you need to know, okay? Because we need those to get those cross-section areas, okay? All right, so let's do a problem and we can start talking about what we mean by all this. So for this, we want to find the volume of the solid whose base is bounded by the graphs of x equals 0. So that would be x equals 0 is the y-axis right here. Okay, y equals negative 1/2 x plus 1. That would be this one. So let's call this one y equals negative 1/2 x plus 1. Y equals 1/2 x minus 1, and that would be this one. Okay, and this would be x equals 0 right there, okay? Now, what we're going to do is we're going to build these so there's with square cross sections taken perpendicular to the x-axis. Okay, so this is the base of it. So they're sitting on this, and then they're coming straight up out of the paper, and what they are squares. Now, here's where our biggest square is going to be, and right here is going to be where our smallest square is. And what it is the bottom of the square is sitting right on this paper, okay? And then it's coming straight up, okay? So this is a side right here of my square, okay? Now, what we need to do is we're gonna start creating these squares right here at 0, but we need to stop them right here. Now, what is that? How can I figure that out? Well, that's where these two are crossing, right? So if we know that y is equal to negative 1/2 x plus 1, and we also know that y is equal to 1/2 x minus 1, where these are equal to each other will give me the x value here, right? Okay, so we have 1/2 x minus 1 is equal to negative 1/2 x plus 1. We're just setting them equal to each other. I'm going to clear out all the fractions by multiplying both sides by 2, and that would give me x minus 2 is equal to negative x plus 2. Add the x over, so that'd be 2x. Add the 2 this side, that'd give me 4, and x equals 2, okay? So this point right here is 2 comma 0, because if I put 2 in here, it's going to give me 0. Okay, so we know that that point is 2 comma 0, okay? And so now we got to get the area, right? So what is this side length, okay? What is S? I'm going to change colors on us. So what is this side length? Well, once again, it's top minus bottom, okay? So the top curve is negative 1/2 x plus 1 minus the bottom curve, which is 1/2 x minus 1, okay? So that would give you a side length of negative 1/2 minus 1/2 x, so that'd be negative x. 1 minus negative 1, that'd be 1 plus 1, which would be plus 2. Okay, so our side length is that. Okay, so now what's our area? Our area of this, so this is one side of the square. Our area would be side times side, right? So that would just be negative x plus 2 squared, okay? Now, we're going to start, we're building these up. So there's a whole bunch of them. We're stacking them, right? And we're going to start stacking them right here at 0. And we're going to accumulate them all the way until 2, okay? And the thicknesses of them are going to be infinitesimally small. So that's my dx. So the volume of this, so volume, let me slide it up a little bit. The volume will equal the integral from 0 to 2 of our area function, our a of x function, times dx. Well, this area of x function is this right here, right? So this would just simply be the integral from 0 to 2 of negative x plus 2 quantity squared dx. And if we find that integral, we found the volume of this solid. So what we're going to do, I'm going to slide it up a little bit, okay? I'm going to do this one by hand, and then the rest we won't, okay? Or at least I don't think I'm going to, okay? This would be equal to the integral from 0 to 2, and then to square this, we'd have negative x squared, or negative x times negative x, which would be positive x squared. When we multiply, we get negative 2x, but I have to double it, so negative 4x. And then positive 2 times positive 2 is positive 4, and then dx. Okay, so then this would be x cubed over 3 minus 4x squared over 2 plus 4x. And we're going to evaluate this from 0 to 2, okay? All right, so this would equal 2 cubed over 3, which would be 2 cubed over 3 minus, and this would reduce to 2 times 2 squared plus 4 times 2, then minus 0 cubed over 3 minus 2 times 0 squared plus 4 times 0. That's all going to be 0, so we can ignore it, okay? So then this would be 8/3 minus 8 plus 8, right? And so we would wind up with a volume of 8/3. Okay? All right, let's do the next one. So this next one, we're dealing with everything that's the same except the cross section's changing. So now we're gonna do an equilateral cross section taken perpendicular to the x-axis. Okay. So right now we know that this point right here again, and we already did it, so we don't need to do it again, is 2, 0. Okay. And so this, okay, is -1. It's going to be y is equal to negative 1/2 x plus 1. And this bottom one is y is equal to 1/2 x minus 1, right? Okay, now the cross sections are equilateral triangles, okay? So that would be this right here. And this is the bottom of the equilateral triangle. And what it's doing is it's coming up, and you can't really see it, but it's coming up and squeezing together, and up here above the paper, it comes to a point, right? So right here, this is my base of my equilateral triangle. Okay, I'm going to draw a picture of it. It's going to look like this. Okay, so that's a representation of one of these. So that's the base right here. Okay, so what I need is I need to find, well, first let's just find the base, right? How long is that? Well, the base is equal to the top minus bottom, right? So again, it's negative 1/2 x plus 1 minus 1/2 x minus 1. That's going to give you negative x plus 2 again, right? So b is equal to negative x plus 2. Okay, now what I want to do is figure out what the height is. Okay, so to get the height, I know this angle is 60 degrees. I know this was 60 degrees, but when I split it, that became 30 degrees, right? And this is a right angle. And because it's an equilateral triangle, and this is the altitude, and it's an angle bisector up here, it also has to bisect this side. So this is the base divided by 2. Okay, so on a normal 30, 60, 90, right? If it looked like this was 30 degrees from trig, this would be 1, this would be the square root of 3, and this would be 2. And to go from here to here, I have to multiply by the square root of 3, right? So this is my height, and instead of 1, I have b over 2. How do I go to here? I have to multiply by this by the square root of 3. So the height is equal to the base divided by 2 times the square root of 3. Okay, so that tells me the base is negative x over 2, right? So that would mean the height is equal to, in this case, negative x plus 2 square roots of 3 over 2. Okay, because that's your base right here. Okay, all right, so what's your area? So the area function, a of x, right? That's the area. Okay, and we're perpendicular to the x-axis, right? So it's going to be equal to 1/2 times the base, so that we're calling that b, right? Times the height, okay? So now it's going to be replacing everything, okay? So 1/2, what's the base? Well, it's negative x plus 2. Times the height, which is negative x plus 2 square roots of 3 over 2. Okay, cleaning this up a little bit, this would equal negative x plus 2 squared, square roots of 3 all over 4. So that's the area function for this, right? This will generate any area for any of these triangles, okay? Equilateral triangles, okay? So now to find the volume, we're going to take the integral from 0 to 2, our area function, right? And we just figured out the area function is this right here, okay? So it would be negative x plus 2 squared times the square root of 3 over 4. That's the area. The dx gives you your thickness, so therefore you're going to have volume, okay? And we put this into our calculator, okay? If you work this out by hand, okay, if you work this out by hand, you would get exactly 2 square roots of 3 over 3, okay? If you use the calculator, okay, to do it, you would get 1.155. And I'm going to just try to go quick so we can get done with this, fairly quickly. And I'm just going to give these to you. I'm not going to show you put them in your calculator because at this point we should know how to put them in your calculator, okay? All right, guys. Okay, let's do, I think we have one more to do, okay? Okay, for this problem, we're finding the volume of the solid whose base is bounded by the graphs of y equals 4 and y equals x squared. So this horizontal line is y equals 4, and this is y is equal to x squared, okay? And with semicircle cross sections taken perpendicular to the x-axis. Okay, so our semicircles, that means the diameter would have to sit on this, okay? So this would be our diameter right here of our circle, okay? So it's coming up off the page and then coming back down on over to this side, right? And it's a semicircle. And this right here would be the diameter of it, okay? Now, we're gonna start creating these semicircles right here, and we're gonna stop it right here. So we need to find these 2 points, right? Without looking at the graph, okay? All right, and the way we can get those is this is a system, right? These two have to be the same. So it would be x squared would have to equal 4, which would mean x has to equal plus or minus 2. So this point right here is 2 comma 4, because we already know the y is 4. And this one would be negative 2 comma 4. So we're going to start making these semicircles at x equals negative 2, and we're going to stop them at 2. Okay, so now we got to figure out this diameter, right? So this diameter would be equal to, once again, it's the top minus the bottom to find this length, right? And it'd be 4 minus x squared. Okay, so we know the diameter is 4 minus x squared, okay? And so we have this shape, right? Because they're semicircles. So it's kind of like that. Okay. And what we know is the diameter here, right? That's D. And what we need is the radius, right? And so to get that radius, we just have to take half the diameter, okay? So the radius, let's come over here. Radius would be this 4 minus x squared divided by 2, okay? So now, because we have the radius, we can get the area, right? So the area function, a of x, right, would be, okay, so 1/2, because it's a semicircle, pi times r, which is 4 minus x squared over 2, and we would need to square that, right? Okay, so this is equal to 1/2, well, we could actually make this pi over 2 times, and then this would be 4 minus x squared, okay, over 2 squared, which would be 4, right? And so the area function becomes pi over 8 times 4 minus x squared squared. Okay, so now we're ready to do the integral. Okay, so this integral for volume is going to be the integral from -2 to 2, okay? And the area, which is pi over 8 times 4 minus x squared squared. Okay, so that's the area, right? And we need thickness to get volume, and we get the thickness by doing the dx, these infinitesimally thin semicircles, okay? All right, so one thing we can do is pull this pi over 8 out. So pi over 8 times the integral from -2 to 2, and then we need to square the 4 minus x squared. Okay, so that would be 16, okay, and then minus 8x squared, and then plus x to the 4th, and then dx. Okay, so then that becomes pi over 8 times 16x minus 8x cubed over 3 plus x to the 5th over 5. So I'm going to do this by hand, obviously, okay? And we're going to integrate this from, or evaluate it from -2 to 2. Okay, so then this is equal to pi over 8 times 16 times 2 minus 8 times 2 cubed over 3 plus 2 to the 5th over 5, and then minus pi over 8 times 16 times -2 minus 8 times -2 cubed over 3 plus -2 to the 5th over 5. Okay, and then this becomes pi over 8 times 32. 2 cubed would be 8 times 8 is 64, so minus 64 thirds. And this would be 32 fifths minus pi over 8 times -32. And then this would be -8, but then times -8 would be positive 64, so plus 64 over 3. And this would be minus 32 over 5, okay? So this would be, I'm looking at this. I'm going to distribute the pi over 8. So this would be 4 pi. Okay, and then this would be 8 pi over 3, so minus 8 pi over 3. And this would be plus 4 pi over 5, because we're going to have some common denominators over here, okay? And then this, when I multiply these, this is going to be positive, so plus, and it would be 4 pi. And this would be negative, minus, okay? And it'd be 8 pi over 3. And then plus, and that would be 4 pi over 5. So some of these you can combine, right? The 4 pi and the 4 pi make 8 pi. -8 pi, -8 pi makes -16 pi over 3. And then 4 pi over 5 plus 4 pi over 5, that'd be 8 pi over 5. Sliding it up. Okay. So we need a common denominator of 15, right? So 15 times 8, 15 times 10, or 15 times 10. 15 times 8 would be 80, 120 pi over 15. And then we'd have to multiply by 5. So that'd be minus 80 pi over 15. And here we have to multiply by 3. So plus 24 pi over 15. Okay. So this would make 40 plus 24. So 64 pi over 15. And that'd be the volume of it. Okay. And then you can put it in your calculator and you'd get 13.404. Okay. Okay, guys. That's it. We're done with AP Calculus AB. That is the very last lesson. Okay. Let me get the assignment sheet and I can tell you what I need you to do so you can be ready for calculus for the next semester. Okay. Okay, so I want you to do page number 410, and then I want you to do 1 through 6 all. And again, I'll take a picture of it from the book because I know you guys, probably most of you turned your books in. Okay. All right, you guys, you take care. Stay in touch. Okay. I'm sure I'll see you around somewhere. Okay. Bye-bye, guys.